How do you rebuild an AI platform when 30,000 repositories are depending on it? When Expedia started using AI agents for engineering work, they redesigned that infra that was designed for humans. Thanigai Vellore, VP Eng at Expedia, tells me how he rebuilt this whole platform for AI agents that humans used to use before. I'm Suresh Mathew. This is One Idea. If you like the show, please subscribe on my YouTube channel. Take 5 seconds. This is one way to tell me that this show has been useful to you. The content here generally is just technical. I just talk shop. No marketing fluff, no BS. Welcome, Thanigai, to the show.
Hey, Suresh. Thanks for having me here. Looking forward to our conversation.
Thanigai, your infrastructure is massive. I mean, literally massive, right? And you introduced AI into this massive infra. What are the main challenges that you faced in that process?
It's close to a year since I joined Expedia. And in this 1 year, AI has really transformed software engineering. A year back when I joined, it was primarily around like vibe coding and AI agents were used for mostly autocomplete, like doing one-shot code generation. But then as the models improved, the agent and the harness improved, agentic engineering kind of started to become a real thing. And when we try to kind of embrace that and push forward and get the whole company going behind it, we did face kind of several problems in terms of how effective these tools can be for software engineering. The first one I would say is our internal platform tools, like whether it's our Backstage, which is our internal developer portal, Spinnaker, or observability platform. All of these tools were primarily geared for human users. Their workflows were largely UI based, and our developer workflows assume there's always a human in the loop. So when you expose these tools now to agents, agents struggle. They can find a way out, but it always comes with a lot of trials and errors. While the agents were really good at coding, but all these other tasks that it has to do with connecting to our platforms was a huge challenge. The second problem related to that is around token economics, where while the agents, as I mentioned, is really good in terms of coding and having the world knowledge, its capabilities around using tokens was actually spent around discovering the context and discovering the problem rather than solving the problem. Because each of these platform surfaces that I talked about, when they are not agent ergonomics, it has to basically work around that problem by reading long pages. It needs to read repos to find metadata. It needs to kind of look at multiple sources to figure out what is the authoritative source of an information. And all the while just like burning tokens. So token economics was also a problem, like where we are spending the tokens.
Did you face it right from the start itself?
You could see it coming, and especially as like more and more the people started adopting it and trying to make progress with this, they were hitting this wall, and the agents were like going into these repeated failed loops. The third problem I would say is around like identity and access. Humans can work through different authentication flows. As I mentioned, like these UI workflows, you require you to like log into multiple platforms. You need to change your environment. You need to like have humans hold a lot of context in their brain and operate with these tools with ease. But these agents are not trained to do that, and they struggle, and they actually have to go through that. Fourth, I would say, is around like the last mile problem. So agents were really good at the 80%, getting it 80% of the way, like the core developer problem itself. But then in the last 20%, it gets stuck because there are a lot of like these proprietary platform abstractions that we have within the company, right? Which models are not trained at. The models are really trained good at like coding, but like if it cannot know an internal platform abstraction that we have created that was primarily for humans in the loop. So all in all, like we can clearly see that we need to change our internal platform to be a lot more agent ergonomic, and more importantly, really treat agents as a first-class citizens of the platform. And he had to do a bunch of steps to make that happen.
And Thanigai, when you talk about internal platform, you're talking about internal, mostly engineering platforms.
That is right. Yeah, this is all about the tools and platforms that the developers would touch and operate on a day-to-day basis to actually get their work done, like anything that is related to, let's say, our internal developer portal, CI/CD platforms, observability platforms, GitHub for source control, things that you need to actually build, design, build, and then test, iterate on, and deploy and operate, like the entire gamut of the kind of developer platforms.
You built the first step, the natural first step, like building MCP servers or layering that on top of your existing tool so agents have access to what it needs access to. What was the process before that?
I explained this kind of state of or experience pre and post MCP with an analogy towards cardio exercises. I would tell my teams that, hey, the pre MCP world really feels like a zone 5 cardio exercise, and post MCP world feels like a zone 2 cardio exercise. Let me explain why I say that. So, pre MCP, as I mentioned, like our platforms are not ergonomic for agents. So the agents would actually, like the work that they would do, and the humans that operate those agents feel like they are having these kind of bursty sprints. And they are able to actually kind of get the context, they're able to accomplish a task, they get that quick spike in productivity, but then spend rest of the time actually working through these fail loops. And so definitely you get like these short spikes of productivity, but but you can't actually endure that, like you can't actually sustain that for a longer time without the context available through meaningful interfaces. When we worked on MCP, we made sure all these tools that I mentioned about have a consistent standard protocol for enabling context of the developer platform to ask very simple questions like, who owns this service? Where is the service metadata located? What is the status of a deployment for the service? When you actually are able to actually answer simple questions through this context enablement that the MCP layer provides consistently across all our platform components, it feels more like a zone 2 cardio exercise where you're in a productive state. It's actually built for endurance. You're actually having that predictable performance that you're actually ensuring. So it was definitely a game changer. And the other part of this is like by leaning into something that is open source, a standard protocol, we are not making it specific for a particular coding agent. We are make this set of services can be used across any coding agent, whether it's Cursor, Cloud Code, Codex, whatever it is. This layer can actually be very effective. So it was definitely helping. And then side benefit of that is token economics and token efficiency that I talked about, right? Here, the responses are well structured. So the agents have lesser time discovering the context and more time solving the problem. So that leads to both faster resolution of the task at hand while also ensuring like token efficiency and token economics are like really good.
So it's basically the efficiency aspect and making sure that this is a sustainable accelerated velocity and not really a spike.
That is right. Yeah, yeah.
Now, Tarmac, the CLI that you've built, it's a chain of tools, and that's a platform that Expedia uses today. Why did you first up design it as a CLI? How does that help the tokenomics aspect? How does it help the developers? And was it a cultural change or a hard to adopt new tech in Expedia?
So as we were actually building our MCP servers and making it available for the coding agents, uh, we we were solving for context enablement with the MCP servers. But as agents were starting to use these these MCP servers, we also quickly realized the command line is a much more natural operating surface for these coding agents to enable platform level operations. So while the MCP servers provides context about the platform, like answering questions around like what is the deployment status of a service or who owns a particular service, if you want to do like platform operations, like check the logs of my service or deploy this service, onboard a particular service, this involves orchestrating across multiple tools within the platform. In the pre kind of, I would say, agentic era, a human would actually log into, let's say, a Datadog UI and look at a dashboard to explain what is happening. Or if they want to actually deploy a service, they would go to Spinnaker and launch something, and then they are always in the loop. How do we actually bring that down to the agents to do it in a very predictable and repeatable manner? That's what Tarmac does for us. Tarmac is like this unified CLI that operates on top of our existing platform layers in a way that the agents can use it to actually create their plan, like using a chain of steps that they can do. The agents can ask these simple steps, okay, list the pipelines that are available for the service, check the logs of the service, and then be able to use that to actually execute a task end to end. Why this is actually important, you mentioned token economics. That's definitely one key benefit. The CLI itself uses the right tools underneath the hood and the right token optimizations underneath the hood, making sure the inputs are explicit, the responses are well structured so that we don't burn a lot of tokens. And also, the architecture of Tarmac itself is, in a way, very much composable. So it's introspectable, it's scriptable, and composable. So which allows us to easily layer in additional platform tools that we need to actually add to this ecosystem. And the agent can actually, since it's introspectable, it can easily kind of query Tarmac to understand what is happening, how to operate on top of this platform. All in all, it basically helped us actually, again, drive the main point I was telling earlier about how do we make sure the agent spends more time solving the problem rather than understanding the problem.
Let's contrast it between a CLI and a UI. So CLI versus API, you're thinking it's almost the same. It's a UI that you just avoided or UX that you avoided.
We were noticing things like the agents, if you didn't provide the agent with the clean interface to actually to a tool, it would do stuff that is
Exactly.
surprising. It'll like launch the web browser, it'll actually read the DOM, read the cookies, it'll try to actually figure out a way to solve it. It's okay, but I mean, you can't get very far with that, and it's not predictable, it's not repeatable, and you're actually burning a lot of tokens.
Exactly. And it's not clean. That's a problem. No, I'm with you 100% there. You had 30,000 repos and you had a decision to make. Either you make it agent ready or you ask the teams to make it agent ready. You chose to do it centrally. Why so? What would have happened otherwise?
Meaning at 30,000 repos, making them AI ready is a massive challenge. And we definitely took this as a platform problem because one of the principles that we follow is to make sure platform teams can act as a source of leverage for the entire company, right? If we have to go ask hundreds of teams to make their repos, 30,000 repos, AI ready, it's going to take a lot of time. It's a lot of cost involved in that. And also, there's a long tail of inconsistency that we need to deal with. So all in all, it's basically something that's not preferred, right? This is where we built a tool called Dev Workbench. Dev Workbench essentially has three components to it. So one is a component for skill creation. The second one is around like targeting campaigns, and the third one is actually like performing changes based on the campaign and the skills that have been defined. So in this case, what we did is basically create a skill that captures all the instructions and the tools and the working knowledge that is involved in making a repo AI ready, including the validation logic and then the kind of the versioning that needs to go along with it. Once the skill was created, now we could actually use Dev Workbench to target these repos in any specific order that we want. And Workbench utilizes the skill to make these changes across all these repos in a very consistent manner. And the output of that work is actually creating a pull request that is actually graded with a risk score, whether it is safe to merge or not. Through this platform, we are able to actually move the entire organization, the capability of the organization, as and when we are able to actually kind of add new capabilities from a central orchestration standpoint. So you're turning something that is a scarce and specialized expertise into a reusable substrate across the entire company. And in this kind of like agentic world, I think that is a very important attribute or quality that platform teams have to embrace on? Like, how do you create leverage for the rest of the company?
So the name of the tool is, and is it open source, Dev Workbench?
This is an internal tool. We might open source it one day, but it's an internal tool.
How long did it take to?
About these days, coding is easy.
Coding
so,
is easy, you're right.
so yeah, it didn't take a long time. It just took a few weeks to build it. We are at the building blocks, and we are leveraging a lot of reusable kind of open source tooling underneath the hood, and it's more around adding the EG specific context to it.
And I'm sure this 30,000 repos had multiple different languages. Was there any language super friendly to you to these kind of exercises?
To the most part, it's language agnostic. What we're trying to do with making them AI repo ready, like what we do with like the instructions around the agents, they're describing the architecture constraints and stuff like that. It's to the most part that the skills cover most of it. We did have language specific validation logic
on the side. Okay. And about architecture, things that were a little older than the newer ones, was there a difference there?
Yes, meaning it's especially like when you have to figure out what are your architecture constraints on your on your like platforms that have gone through several cycles of evolution. You'd have to make sure that you're picking the right kind of authoritative source when you're actually describing that context of the service into your repositories. Those are things that we are actually kind of also solving it by having like centralized repositories with knowledge bases, things like that.
So legacy versus non-legacy, the good thing, what I've heard from our customers is they had a very like super legacy something, almost treated as a black box, right? And when things fail there, we either call the developers who did that and bring them back and do stuff. They did some experimentation on it, and that probably is where they got the most ROI. They said now it's almost accessible to everyone, and almost everyone can fix it. And in most cases, it's not heavily used. So even product managers can now come in and say, you know what, this was the problem, and let's fix it.
And that's a key thing, right? How do you reverse engineer spec from a system that's already there, where there is minimal documentation that's available, or a lot of documentation that's available, but you don't know what is the authoritative source. You need to actually kind of like now have the agent read the code and kind of reverse engineer what the spec would have been for that, and then that becomes the context for future iterations.
Or maybe the other option is just don't even worry about like the spec of it. If there's something happens, this agent will take care of it. All right. So Thanigai, back to the chains of tools that you have and the framework. It's all designed for humans to consume today, right? So they understand how to go into something, figure out how to do stuff. You're now exposing this to the AI agents, right? Which means now you are exposing something that's not designed for agents, that was clearly designed for humans, and exposing it to agents, and you expect this to probably be like very clear to the agent and be able to repeat this on multiple other chains too, right? What was your strategy in exposing this?
It took a very incremental approach towards this. Our first step in this journey was definitely around context enablement and context engineering. That was the first step that we had. And that's where our effort towards our MCP servers came in, basically bringing in context to these agents about our platform layers. I talked about our development platform layers. We also did the same for all the rest of the other platforms, like our data platform, our agentic platform, and so on and so forth. So basically, making every single platform layer also have an MCP counterpart so that the context layer is available. The second that I mentioned around like specifically geared towards engineers was around the Tarmac CLI that allows for not just context, but also platform level operations that you can execute, right? So this is important so that the agents can reliably go and execute a particular task end to end, whether it is a build task or whether it's a test task, whether it's a verification loop, whatever it is, right? They should be able to actually do that pretty independently and pretty and reliably as well. Then we started focusing around like more upstream on the process, which is more around the analysis and design phase. How do we make sure that the agent understands the architecture constraints that we have within the company? How does it know how our cloud foundations, how the foundational layer works? How does it know what security parameters and security kind of architecture constraints that we need to take take into consideration when developing new features or developing new platforms. This we approached through in two ways. One is about centralizing the information that we have about our architecture constraints, facts around our platform itself. What is our like VPC topology looks like? How does service discovery works? These are like very critical things that the agent needs to understand. So we created a centralized knowledge base. Back to what I was talking about, like having the agent going and figuring out what is the state of the world and representing it back in the form of specifications. That's what we invested in. So we now have a very good set of skills and agents that are actually understanding the state of the world, and by scanning what is around there, both the real representation of the actual physical infrastructure, but also based on what documentation exists, and in a centralized repo. To answer your other question around like how do we make sure these internal platforms that are geared towards humans, how can we actually make it agent? We took a very aggressive approach in that by creating a monorepo. It's called Coda. It's where the only contributors into that monorepo are AI agents.
Wow.
This monorepo, you can think of it as a control plane for our platform itself. So you can think of it as like while the platform itself is an engine, the Coda is the cockpit that basically operates, gives you control over that engine. Within Coda, it provides the interfaces that both humans and AI agents can access to get a good sense of the state of the world and also do operations on it. Where the only contributors, again, as I mentioned, is the hard constraint is the contributors needs to be AI agents, which means that it needs to have 100% context into the platform with well-defined specifications and set of skills that drive these platforms. So we have more than 15 different agents and skills that operate on this monorepo automatically to basically provide that control plane for our operations.
And what does that control plane do?
The control plane gives you, like today you have different tools. Like if I have to onboard a service, I need to log into Backstage, which is a separate interface.
It's almost like the dev control plane.
Yeah, it's a dev control plane. Or if I have to go to look at a deployment, I need to go look at Argo CD. If I have to initiate something on CI, I have to go to GitHub, right? Coda is basically centralizes everything. Right? You just have to log into Coda. And the contributors to Coda are actually AI agents, which means that we can continuously evolve this thing, keeping in mind the other persona, which is like humans are always there, but like the other persona is now AI agents.
Let's go a little deeper into that. On Coda as a platform is all done by AI agents. The users are all, I'm still thinking the developers.
It actually also exposes, so all the specifications that are required to build those interfaces are used by AI agents as well. You can actually have AI agents introspect Coda to get a context into what is happening. So it's the users of Coda are both humans and AI agents. The contributors are AI agents.
The AI agent users are generally there to validate and test.
To build other new products.
And are there new products being built in Expedia that's like initiated by AI agents?
No, it is, we have not gone there yet, but yes, yeah.
That's the path.
That's the
so ideally it's available for that too.
Right, that's right.
Now let's go a little deeper into that. So now, what phase are you in terms of that Coda maturity?
Yeah, so we have something in this kind of talking about maturity.
No, just for the Coda platform.
For the Coda platform, I would say we are right now primarily focusing on the developer workflow around design and implementation for stateless services. We have not yet integrated into some of the other personas like analysts, data scientists, machine learning, those kind of things. So it's, I would say, primarily around software engineering persona. Tools used by, I would say, like persona and corresponding AI agents is what is being targeted by Coda.
And backbone is really Backstage.
Yeah, it's I mean, all these tools that I mentioned about it. In some cases, it's Backstage. In some cases, it's GitHub. Some cases, it's Spinnaker. And you could actually swap it underneath the hood, and it'll still be invisible.
Are you considering open sourcing it?
Maybe yes.
Maybe it's a good candidate for the rest of the world to at least see and adopt, right?
Yeah, definitely. Some of the principles used within Coda is worth highlighting. I think the importance around like how spec-based development and making the agents the importance of having these different skills and the different phases, like you having a skill with a strong intent, translating a spec with a strong intent into a low level design, and taking that low level design and then doing the implementation and then also testing it, right? Each phase has a well defined acceptance criteria that the agent can actually use, so that the context is not lost, rather the context doesn't get rotten, because that's one of the biggest problems. Like you see a lot of giant workflow loops that happen. The initial first 5 minutes or 10 minutes looks promising, but as you start getting with deeper and deeper without having a well written intent or spec, is that you start having this context rot problem.
Now, about your dev container, right? So you have a dev container and it has built in security, tokenomics, and almost all sorts of efficiencies built in, right? How did you come up with that, and how was the adoption, and what was is it at the maturity that you want it to be?
For us, the dev container really helps us standardize rollout of new capabilities to the broader engineering community within the company. Dev containers really uh, ensures it gets it's packaged as part of. I talked about AI repo readiness. Every repo also has configurations for setting up dev containers, and these dev containers come up with the right set of agent harness built in, the right runtime that needs to be provisioned, the required steps for having the right corporate certificates enabled, having the right token optimization techniques already embedded, the right skills, plugins, all of those things that you would want every engineer within the company to use, so that we achieve a few things, right? First one is token economics that I mentioned. Like we want to make sure that more tokens are used for solving the problem rather than just discovering the problem. Context enablement is there. Security is important, right? Because with dev containers, you're actually setting up a trust boundary. You're making sure the agents only have access to what they need to actually
Do
do
the
the
job.
task. And then it's very much portable. You can run the dev containers locally, you can run it remotely, and you can get that predictability. And that's very important, especially as we shift more towards kind of autonomous code delivery. Going back to what I was talking about, like creating leverage for platform engineering teams. In this agentic world, like dev containers is a boom, because you can actually like encode all this best practices and then distribute the dev containers and create a huge leverage by bringing in standardizations, adhering to best practices in security and architecture and things like that.
You talk about this AI maturity model, right? And I'm sure the teams are walking through that. And what do you unlock in each of these phases?
So for us, AI maturity model really provides us sort of a shared language for everyone within the company to understand where our true North Star is, where we want to get to, and also get a baseline of where we are. And we look at it both from a breadth and depth standpoint. Breadth is more about like coverage within the company, like how many teams are able to actually embrace these tools, and how far we have actually enabled these tools to be. And then depth wise is like what are the capabilities we are actually, how far we can actually get into the SDLC to actually kind of create impact with these tools that we have. We have like 5 levels. The first level is, I would say, is AI assistance. This is basically the basic vibe coding or autocomplete that we all did like a year back. And this is good for like one-shot code generation, but that's about it. Level 2 is more around context awareness. This is where the MCP servers and the Tarmac that I talked about like really help. So where we are actually enabling the agents to be more efficient, more productive in doing some tasks.
And mostly again, coding tasks.
It's mostly doing the coding tasks, and the humans are still driving the execution. With the context awareness, the agents are becoming a bit efficient.
So basically, agents are on the execution side, and humans are on the validation.
Not yet. Like I would say, in this phase, we are still agents are doing the steps, but the execution of that step is actually largely done by humans.
I see. So they are still in the driving seat.
Yeah, that's right. Humans are in the driving seat. Level 3 is the agentic execution, which is what you're referring to, where the agents are able to do complete execution of a step. And this is where our work on, like, basically once you have a dev container with the right kind of skills and the right MCP servers and all this end-to-end setup completed with your spec-based design that's coming in, then your agents can actually now execute, really execute independent steps. And level 4 is agentic workflows, where you now talking about not just like a task, but you are actually have like multiple agents coordinating with each other, taking anything from input requirement like in a PRD, and then translate that, go through the spec driven development, and then translate that into an output product at the end. The work that I talked about in Coda in terms of like how spec driven development is coming in, how do we actually institutionalize that and make it more broadly available for everyone.
And is there an adoption slowness that you see anywhere?
Our focus currently is making sure the platform layers. We want to work from the platform layers all the way up, so that way, because the platform layers are the ones that are actually the most dependent services, because everyone depends on that. And then then you have next level of services, which are like your domain services. Then so we are basically in that journey of making sure we are able to actually get more and more of spec driven development across the company through these different layers. Fifth is AI first teams. This is where I would say humans and AI agents are part of the same team. Pick and choose work and operate. We are not there yet.
Now, about the adoption slowness, one thing I have noticed is typically people are excited about AI when they see it first, because now you see a lot of stuff happening. It's fun. Then the excitement starts dimming once you get to the reality that, you know what, not really, right? Now I have to ask questions. It goes down further when you see a problem in production and you don't know how to tackle it well, right? That's when I get people not unhappy, but they are upset about what's happening now and they don't know how to recover, right? How do you prevent that from happening?
That's a great question, and it's a very real problem, right? All this vibe coding and like giant loops that are there are good for quickly building products, like quick to show, like demo prototypes and all these things. It's very, very effective to actually show an idea in action, but it's not like really suitable for production grade applications. To really actually build something that's of production quality, that is capturing the full intent, both from a functional standpoint as well as from a non-functional standpoint, we need to really kind of bring in some of the best practices in software engineering that is always there, right? Around writing good specifications and validating that specifications with practices like test-driven development and so on and so forth. That needs to be really imbibed, and this is where like there are like different approaches to it. There's like an approach called which is like BMAD, which is basically taking how some of the best practices in software engineering, but making it like adaptable for like AI agents, or the approach that we are using with like Coda, heavily geared towards like spec-driven development with like purpose-built skills and purpose-built agents that actually validate every step along the way. Whether it's an analysis phase, the low-level designs, for each of those phases, there are like well-defined acceptance criteria that different agents are involved to actually make sure that the work that is done by one agent can be actually validated by another agent based upon a well-defined acceptance criteria. And that's how you can actually ship production grade quality and software. These skills are like not just prompts, they are actually versioned, immutable kind of artifacts that really explain the behavior of your system at any point in time.
Clearly, the code production is easy now. The cost has dropped, but the platform operating cost, I'm sure, spiked.
Everyone talks about the Jevons paradox, where it explains that if the cost of something goes down and basically the usage of that actually goes up exponentially, And that's definitely what's happening with software today. Very few are talking about what it actually means for platforms, what it actually means for platform engineering. While the cost of development has drastically gone down, almost like you can say marginally, it's zero now. Cost of operations have gone up significantly, and not a lot has been talking about it, but we see it on a day-to-day basis because you have more number of PRs, more logs that are instrumented, more observability data, more everything is more from a platform
Management standpoint,
Yeah.
yes.
So the cost to operate has definitely gone up.
Yep.
And also from the side effect of the tokens being used is kind of also exploding along the way, because tokens are not just used for development anymore. It's used for everything else as well, like to analyze logs, to actually to monitor services and things like that. And this is where, again, going back to what I was saying about like platform teams creating centralized leverage comes into play. Like we are working through embedding these best practices around like token efficiency. How do you optimize tokens? How can we package that and roll it out more broadly using dev containers? How do we distribute? Like we have a centralized repository for where our skills and plugins are managed. So we make sure that as we are figuring out problems or optimization opportunities, we can actually encode that into a skill and roll that more broadly. Those are some of the things that we are kind of doing to make sure we can lean into AI to kind of like gain the productivity advantages and but also not like blew the bank.
What is one thing that most platform teams get wrong, or when they make their infrastructure friendly for AI?
I would say, like, if I have to pick one, I would say avoid building thick platform abstractions. It is very easy and also sometimes exciting because the cost of development is nothing these days. To start building like thick platforms that abstracts a bunch of tools underneath the hood and just and providing an API on top. It works well from a platform elegance standpoint for the platform team, not so much for the overall industry, because this industry is moving at such a massive pace. It's like moving at a much faster pace. So any abstraction, any thing that you're going to put in front of it can be like not compatible within a couple of months based on where the industry is moving to.
How do you suggest they build? Because at this point, if you don't abstract, everybody will have to move to the next version.
Yeah. So that's where I think like composition works better. Composition versus abstraction better. You'll always have some layer of abstraction, but make it fluid. Like you compose on top of primitives. Compose on top of primitives that the agent can understand. The models are trained on world knowledge. It knows or what is out in the public, and the agents can work with primitives that it can understand, like the MCPs, servers, and well-described APIs, right? As long as we can lean more towards these primitives and compose your platform on top of these primitives, then you are keeping the options a lot more open while embracing, basically making it easy for anything that the industry is actually coming up, right? I'll give you an example here. So we are building this tool called Ampersand, so which is you can think of it as a fire and forget remote agent worker, and we are exposing it as a form of a plugin, and you can expose that, and we are exposing it in multiple forms. What it is it's a very thin layer that actually sits on top of underlying platform providers. Like let's say it uses Claude's remote agent. You could actually tell Ampersand, hey, launch this complete this task. Here is a prompt. Here is a set of skills that you need to use, and you can actually fire it out. And internally, it deep links into like Claude remote agent. So by actually providing a very easy way for us to kind of capture the context and almost like act as a gateway to just send it to the right source, you're sort of like leaving options open and not
You're not stuck with one
with
agent.
one, yeah.
This must be valuable for the rest of the world also, because that's one thing that I'm sure people are worried about. If you get married to something, are you stuck there forever? And it could be a favorite agent. It could be a type of I mean, even some skills that I've seen, people are not happy that you're not able to move away from that, right? Because we start using it heavily. Now it may not be the most efficient, it might not be the smartest skill set there, but now you're stuck because everybody else is using it. So those things can be decoupled and move fast. So is there any plan for you guys to open source any of this? Maybe not even open source, maybe blog about it.
Yeah, definitely. We are blogging quite a bit, and open source is definitely an option as well. We are a little early on ampersand, but yeah, we might do it one day.
Thank you, Thanigai, for coming and talking to us about your one idea. First up, the best part about this conversation in my mind is these are the leaders who took this journey with a lot of courage. I'm sure there are a lot of mistakes that they've learned along the way, but this kind of information would help us, not exactly a paved path, but at least a path that is proven to be successful elsewhere to be taken. So enjoy the show. Thank you, Thanigai.
Thank you, Suresh. Thank you for having me here.